thoughts and share it with you. Have you ever tried to convince anyone that functional programming matters? Can you lift a hand? Okay, have you failed? Okay, same hands. For those of you who has really limited attention span, I've prepared quick answers, but it's not so good as the talk itself, so let's go further. Every time I mention FP languages, I really mean pure statically typed functional languages. And let's go over some points why it's good, why it's called functional. The first point is really simple, it's really basic. If we have referential transparency, every time we call a function, every time we evaluate the expression, we get the same result. It's a necessary building block to build something good. And the other half of it is persistent data structures. And this is also good because we get equational reasoning out of it. It means that when we isolate a piece of code and we look at it, we may go clause by clause and reason about it and see what it really does. It doesn't really possible in languages, in imperative languages. And lately I've seen a movement. Some person was creating a list of companies that use whiteboarding. That means they use whiteboards in job interviews. And it seems really ridiculous to me, but then I thought about it a little bit more, and I got it. They use C++, and it's really not possible to reason about the code if you have global states, mutable data, and logs, and this kind of stuff. And you can do this easily with functional programming. We do it daily with a whiteboard in Office. We enable ourselves to use many concurrency and parallel programming primitives this way. I can go on and on about concurrency, but sadly we can only scratch the surface here. And when we immerse into functional programming, we find ourselves in environments where we are exposed to the academical publications, papers, and a lot of concepts that's not really here yet, but we'll see them in industry. And some of them, it took like 3 decades for some of these concepts to not really get mainstream, but to get a valid implementation. But this distance will become shorter, and I encourage you to be on the bleeding edge and to know about these concepts. The most important thing about selling and teaching anything is knowing your stuff. So go read a paper. If you encounter a new problem and you've seen the theoretical solution or some approach that may work or may not work, it's already good enough. It's called experience, it's called professionality. So let's go to the functional abstractions. And we really get that from maths, and the most of these abstractions were researched and documented in academical papers. So when functional programmers speak about monads, coalgebras, and stuff like that, they really know what they mean, and it's really precise, so it's good. It's not like an ad hoc pattern you can see in some web framework. It's not like that, it's really precise. And I had a story in my work. We had a task of rewriting a piece of Ruby code in Haskell. And I asked a developer to do that, and he's going through the code, and he's like, I don't know Ruby, I can do that. And I tried to explain it to him, and I wasn't very successful until I found the right description, and then I said it's basically fold M over the list of handlers in except T API error IO monad. And he's like, oh, now I get it. And if you know the concepts, it's really easy for you to get something, but if you don't, just learn it. And the best documentation you can get for this kind of jargon is math books and papers. But is it ready for production? Of course it's ready for production. You use it every day. You use it on a daily basis, I can guarantee that. Facebook uses Haskell for anti-spam. And have you seen any spam on Facebook? I have not. I guess it's really good. Twitter is powered by Scala. WhatsApp uses Erlang. We use Haskell and we're really happy, so sometimes we have to speak with business people, and it's really getting us out of our comfort zone as developers. It's a scary person in a suit, and you don't really know how to talk to him. And first of all, throw all your preconceptions away. If you having some kind of technocratic thoughts in the back of your mind, throw it away. Successful business people are really smart, and they are really good at their job. But they don't think like you. They don't solve the same problems. And you have to understand that when you're speaking with them. And first of all, be the advisor, be the teacher. When you try to make a point for your programming language, for your project, you have to state concisely why it's good. Why does it matter? And if you can leverage the community, for example, I consider Haskell programmers on average are much better developers than Java developers. I'm not saying that Java developers are bad. I'm saying that the average level of expertise are higher for Haskell developers. And it's always good for business. And you can really, in concise form, project that thought to your boss. And when I'm talking about average, it's really important concept for managers and business people alike, because they don't share your vision frequently. If you want really correct software and you want to make the most out of type level and stuff like that, it's not always interesting for business people. They want mostly correct software most of the time. And as advisor, you should show the possibilities. And if it's really about the bang for the buck, you should go for it. I want to reference an old article. It was called Beating the Averages. It was written by Paul Graham, and he was talking about some average programming language called BLOP. And he was referencing the BLOP paradox. If you're a programmer in BLOP, you think in BLOP. So when you have to solve a problem, you try to find a solution that will work with your tool of choice, BLOP. And if you try to compare it with some other tool that might be more expressive you can't really see how it's better because you don't know the concepts, you don't know how to compare it. And it was called a blob paradox by Paul Graham. And when I say blob, I say Java. So keep in mind the concept of average. It's really important. And when you say an average, it means that when you have to maintain a project, you'll be looking for average developers. You won't be looking for geniuses or researchers. It will be an average developer that will maintain your project, and if the average developer are better, it's better for business. Do we have any team leaders or CTOs in the audience? Okay, a few hands. If you can, go create some jobs with functional programming. And the most important point is bring something valuable and then show the value of it. Don't go the other way around. It's like my boss don't see the point in using Java, Haskell, blah, blah, blah. Just make a tool. Make a tool that will help your current project. Make it in Haskell, make it in Scala. Show how reliable it is. And it will get your team working in this direction. It will get the job done. There's also a thing I call the drug dealer strategy. Basically, what it means is drug dealers take something that has a real hook, and they give it for free. And now someone is hooked. You can do something like this. Make a really good project and then say, do you remember the previous project? It was failing all the time and stuff like that. And it wasn't really reliable, and then I made this, and by the way, it's made in Haskell. Yeah, it's a good way to really teach people that one technology can be better than the other. Or, for example, you can make something work in less time than it would take in another language. So, yeah, make the most of it. And the really scary part is correctness. We want mostly correct software, but sometimes it's not enough. Just imagine the medical equipment you've been diagnosed with is faulty, or you're strolling down the street and la 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 la, and there's a drone above you and it's undefined, it's not a function, and it's falling on your face now. It's not really good. And there are lots of examples of criminal coding in modern human history. People were killed by faulty software. One of the most known examples of it is a machine called Terac 25, and it was a radiation therapy device that basically gave a little dose of radiation to some people because of some overflow error or something. I don't quite remember. And we lost, NASA lost a Martian climate orbiter because they messed up the units of measurement, and the orbiter got burned up in the Mars atmosphere. Sometimes it's really bad. So only the functional programming has a verified software solution. We have theory improvers and verified software. I encourage you to look at it. For example, CompCert is a C compiler that's proved to be correct to the letter of the specification. And it's written in Coq and extracted from Coq. Another great example is a library and suite of languages called Bedrock. It's also written in Coq. And you can go all the way to the low-level languages and write code that's probably correct. Of course, that's a radical kind of thought. And for the most tasks in industry, we want a good approximation of that. We want something that will be able to get us to the result faster, and we don't want it. We don't want the software that's made with it to be faulty. We want to sleep better as human beings and developers. And the other thing I hear as well, and really frequently lately, that we have all this functional programming machinery in mainstream languages. Java got lambdas and stuff like that, and we have lenses in JavaScript. Is it enough? No. No, it's nearly not good enough. It's really bad. And we want tools built from the ground up, from the right principles, from the right fundamentals. And we want to really explore that space, explore these concepts to go further, to build a better software. I'd argue that type systems are really important, and we have best-in-class type systems in functional languages. We had a talk about Scala type-level programming, and it's really good. You can do this stuff with Haskell, probably to some extent with OCaml. And we can go even farther down the spectrum to Agda, Idris, and other Terra improvers. Let's make better software. It's really sad that good software today is the software that's not really messy, and it's kind of okay. And we can make better software, and the movement and inertia we get with functional programming recently is it's not enough. So go make a project, go bring it to your boss, and teach yourself, teach your colleagues, teach your boss if it's necessary, teach your clients. It's always good. Thank you.
Okay, any questions?
Maybe have two. The first one is about teach, and about this blob paradox. Don't you think that by teaching a lot, you will make this pure, beautiful functional language blob